The rational zero theorem is a theorem that's used to find out the rational numbers that potentially can be the factors of a polynomial. In other words, if you plug in the rational numbers, then it would potentially produce a remainder of 0 of f of x. So the whole goal here is to figure out what are the possible numbers that are ratios that can produce a remainder of 0, rational zero theorem. The rational numbers are p over q, and what that means is that your p are going to be the factors of your a sub 0, and your q are going to be the factors of your a sub n. Those are going to be all possible ratios that could produce a 0 as a remainder. I think it's easier seeing an example. Let's take a look at number 1. Your p over q are going to be, again, the factors of 20 over the factors of 1. So that's going to mean it's plus or minus 1. I'm looking at factors of my p, so it's 2 plus or minus 4, 5, 10, and 20. Now, all of these numbers are possible rational zeros. They're listed out. If this number here was a 2, then you'd have to also include those numbers divided by 2, and there would be some duplicate numbers. But it's not, and so those are the possible rational zeros. Secondly, the question is find which are zeros. So what I would do is, first of all, start plugging in 1 and negative 1, 2 and negative 2 in for here, in for your h of x, and determine if you have a remainder of 0. Then you can use synthetic division and factor. So if I first start with 1, I would have, okay, so I'm just going to do a little shortcut up here. It's going to be 1 minus 5 minus 4 and 20. That does not work if I use a negative 1. It's going to be negative 1, negative 5, 4, and 20. That does not work. Jumping to 2, 8 minus 20 minus 8 plus 20. That's going to be my first factor. So then what I would do is go down to, knowing that the factor is 2, that means that x minus 2 is going to be your polynomial expression, or written as that factor. So, so 2 is actually going to be the number that you're going to use for synthetic division. And so, let's see, I'm going to have 1, negative 5, 4, 20. And this of course should equal 0 when you do this. And luckily it does, and again you're looking at those factors. So to write h of x, I know that x minus 2 is my first factor, and the second one is going to be x squared minus 3x minus 10. Then what I would do is factor it down, or try to factor it down, and see if there are any other rational factors. So this is going to be minus 5 and plus 2, and so now this completely factors. Now if it didn't factor, you would stop at this point as well. This is fine on this problem. However, if this was an ACT problem, I would look and see, can I factor that immediately? And that answer is, you know what, you can by grouping. And so I can take out an x squared, and that's going to leave me with x minus 5. And then I can take out a minus 4, and that's going to leave me with x minus 5. And now you can see that h of x is equal to x squared minus 4 times x minus 5. And that is going to yield the same result that I have up above. This is not always going to be easily factorable, but in this case, you actually could do the same problem by using this method. So, rational zero property or theorem lists all the possible rational zeros or the numbers that will yield a remainder of 0. And then you can substitute those in, see which ones give you a 0, and then use synthetic division to get your remaining polynomial, and then try to factor that.